Here we have a 2004 Yamaha two-stroke 90 horsepower outboard with a stator, and we just converted to an Epic Batteries dual purpose cranking and deep cycle lithium iron phosphate battery. Now, how to charge these using an older engine like this is what we're going to talk about today. Now, this is a very confusing topic. There is tons of information out there. Some of it's good, some of it's bad, some's misleading, some's incorrect, and some people are just don't even know what they're talking about at all. So it makes it very confusing, even for someone like me that's been professionally working on boats and outboards for well over 12-13 years now. So this is going to be every piece of information that I can get my hands on, and the way I'm understanding this issue of using a lithium iron battery, which when I say lithium battery, I am talking about lithium iron phosphate, a Life PO4. I'm not talking about NMC or lithium ion or any other chemical makeup of lithium ion, because I just wouldn't put that on a boat. I think Life PO4 is pretty much the only type of lithium that you should be putting on your boat, and so that's what I'm going to be talking about, is the lithium iron phosphate batteries. Now, when it comes to charging a battery, especially a lithium battery has a battery management system, which is a BMS. That controls the battery, which keeps it from overcharging, overheating, overdrawing, or getting too low, spikes, anything like that. Like, the battery has a system that manages it, which makes it safe, and the BMS can shut off at any time. So one of the biggest problems that people talk about is that the battery disconnects from the engine. A very prominent issue with like an F300 or the 4.2 liter Yamahas. Now, when it comes to charging this battery, one very crucial piece of information to understand is the way that an outboard charges a battery. You have either a stator or an alternator. A stator, which is used on Suzuki's, Yamahas, and many other types of outboards, two strokes, is a stationary rotor, which means that there is a stationary rotor that has, or a stationary stator that is stationary. It does not move, and the flywheel has magnets that go around that create your electricity. It then goes to a rectifier regulator, which rectifies and regulates the voltage coming out of it. That obviously is going to change with how much electricity the stator produces as your RPMs increase. So the faster that the engine goes, or the faster the flywheel spins, the more electricity it produces, and two strokes can be completely variable. I mean, some Johnsons out there are going to be putting out 17 volts, which is extremely high, and that can damage a lithium iron phosphate battery, which is why it does not work. You cannot use a stator with a lithium battery, because the spikes in voltage will make the BMS disconnect. It will shut off and stop discharging, which means you're running your engine and it completely disconnects. Back to the issue with the F300, if it disconnects, you can damage the engine, you can overheat the stator, multiple problems can happen, because when you disconnect a battery from an engine that's running, and what I mean by disconnect is that if the battery and the engine are no longer connected correctly, like if it's complete hard disconnect where the engine no longer sees the battery, most models the engine's just going to shut off. Some models, depending on how it's set up, the engine will still run. It'll just be running on its own power. It'll be disconnected from the battery. Another type of disconnect is a loose connection, a loose ground, loose power cable, dirty connections at a battery switch. Stuff like that will cause a disconnect from the battery on the engine, or it creates resistance in it, which can cause you problems. So that's what I kind of mean by disconnect, is that if the BMS shuts off because of a voltage spike or something like that that causes the BMS to turn off, it is a hard disconnect, which usually, like on a F300, the engine's just going to shut off, but other engines will it'll react differently depending on the model that you have and how the charging circuit is connected to the battery, whether it's isolated or not isolated. That also plays a factor in this issue, but we'll talk about that a little bit more here in a little bit. A lot of times, depending on how hard of a disconnect it is, the engine will still run, but like if an alternator, well, that's completely different. We could talk about that really real quick. An alternator is the other type of charging system that an outboard uses. Most modern alternators, like on Mercury's and other engines that people are using now, have a built-in rectifier regulator, and it basically acts like a fan. So as the alternator spins faster, it cools it down. So the higher the RPM, the cooler the alternator goes. If that alternator does not sense charging voltage, it will try and put out as much voltage as it possibly can. That is why some people don't really know this, but if an alternator does not see the battery, it does not see that it's charging, it will increase the amount of voltage that it's putting out until it sees charge voltage, which means that it's charging the battery. An alternator at wide open throttle, or even not even wide open throttle, it can produce up to 24, 25, 26, even 27 volts from an alternator that does not see a battery. So if the engine is able to run and it does not see that battery, that alternator will put out that much voltage, which is going to damage everything. Completely dangerous with this. It can burn up the alternator because it's going to overheat because it is producing all the amperage and all the voltage that it can produce at the same time, which is obviously a problem. Stators, on the other hand, do not have this type of protection. A stator will just continue to produce and produce and produce, and it uses an external rectifier regulator in order to rectify the AC voltage and change it to DC, as well as regulate it so that way if it's getting, it stops it. It's not going to produce more than, say, 15 volts or 14.7 or 15.5, depending on the engine. Two strokes vary a lot. Older engines that use stators, even newer engines that use stators, there's a variable there. It can spike, and especially at startup and shutting it down. So those spikes or those issues with a external rectifier regulator where it does not regulate it properly, it will cause a problem with the BMS, which can make it disconnect or make it do other different things that can damage the alternator, the stator, or it could damage the battery. It could cause you all kinds of problems, which is why you can't use a stator with a lithium battery unless you have something like this. This is a DC to DC charger. So what this does is it acts as a rectifier or a regulator, basically. So the voltage from your rectifier regulator that is on the engine needs to take its charge voltage, come out of that rectifier regulator, and go to something like this. It will come in and then it will go out. So what comes out of this is totally controlled. So there's a ground right here, there's an out, and this completely controls it and regulates it, and that way you do not have voltage spikes, you do not have amperage spikes, you do not have any kind of issues coming from the stator and the rectifier regulator coming from the engine. And you would just take this out, go to your battery, being your battery you're trying to charge, and that is how you're going to be able to charge it using an older two-stroke, something like that. Now, there are other people that I have seen and I have read about that will take a different rectifier regulator on the engine and completely swap it out. I have not really done that, so I don't have a lot of information there. I know a lot of people that have Yamahas, like if you got, say, a 92 stroke or something like that, they will take a rectifier regulator that is built for lithium-ion batteries. A lot of them go to motorcycles. So Yamaha makes motorcycles. There are other motorcycles out there that people are taking the rectifier regulators off the motorcycle and swapping it out for one that can sense a lithium-ion battery, or I don't know if it really senses it, but it just has the regulation properties that make it usable with a lithium-ion battery, and therefore it makes it usable because you eliminate those spikes and the other issues of overcharging or overdrawing. Because if you overdraw, because there's a lot less resistance in a lithium-ion battery than there is with a lead-acid battery. So that less resistance means that it's going to be able to pull more power, or the alternator is not going to have to work as hard, and it could just produce more. If it can produce more, then the amperage is going to go up, and that's how they burn out. You burn up the stator, you burn up the alternator, which is a problem. those rectifier regulators that people found that match the same one that's on their engine, like the 92 stroke, it's a very simple rectifier regulator. And you can have a very similar one that goes on a motorcycle, and they'll just swap those out, and that seems to fix the problem. Me personally, I have not tried that. I think that going with something like the DC to DC charger, again, I'm going with the 30 amp. You want to go with something more like a 30 amp because like they make an 18 amp, which it's going to take you a very, very long time to charge that. Now, all of this is totally going to be dependent on your outboard. Do you have a 300? Is it a 350? Do you have a 200? Do you have a 9.9 horse? Do you have a 40 horse? Like, what is your outboard? And also, what is your boat? How power consuming is your boat? If you are running 3 MFDs on the boat, you're running a 3K transducer, you're running, you know, two 1200 watt amps for your stereo with 2 subwoofers and 8 speakers, and you're using all kinds of lights and live well pumps and all kinds of stuff, then you're consuming a ton of electricity, which 30 amps is not going to keep up with that amount of consumption, which is going to overwork your alternator and your stator. The battery's not going to be able to keep up. I mean, it's going to be a problem. So realistically, once you get into that aspect, there's a lot more calculations and a lot more considerations that need to be done. But if you got a plain Jane simple boat, like a lot of people do, you've got a 90 horsepower outboard 2-stroke, and you just want more power and more, you know, stable power on your boat, and you want a battery that's going to last, say, 11 years, 15 years, then the DC to DC 30 amp charger is going to be a very good option, because if you're running just a simple chirp transducer with a 5-inch GPS screen, you're running a simple 2-speaker radio, and you've only got 1 live well pump, like the amperage that the engine is producing and charging your battery is going to be able to keep up with your consumption. You're not going to have any concerns there. But if you're on the other side of that and you've got twin 300s and you've got all that stuff in the boat, then you might have to do something else. There are people that are running multiple of these. So if you take, you know, 3 of these, because depending on what the alternator is, some of them will produce 70 amps, some will produce 90 amps, some will produce 120 amps, depending on the amperage that your alternator is producing, or your stator, depending on which one you have. Most modern alternators, like most of the Mercuries, if you buy a brand new Mercury today, for the most part, most of them all are good to go right out the box. They can be used with lithium ion batteries. That's because Brunswick owns Mercury, Brunswick owns Relion batteries. 2 or 3 years ago, they put out a service bulletin that you can use lithium with their engines and not void your warranty. It's all dependent on the type of battery. You need to have a good battery with a good BMS that is going to have the right specifications and be able to be used as a starting battery, depending on, again, your engine. Then all that plays into this whole discussion. But people are using 2 or 3 of these in parallel, so the charge voltage is going to, say, 3 of these, which at 30 is going to give you 90 amps of charge. I'm sure it doesn't work out to exactly 90. I'm sure there's some drop there, and maybe it's 85. I don't know what it may be, but that's how they're able to use all lithiums in their boats. But it's extremely important that you consider these things, and when you're thinking about going from a lead acid to a lithium and trying to charge it with an older 2-stroke, you pretty much just have to go to your rectifier regulator, you have to cut the wire that's giving you charge voltage, and then you have to use these things, which are breakers. You can get any kind of breakers that you want. These are resettable. You get depending on how far you're going, you know, if you're going 20 feet, then you're going to need like a 6-gauge wire and probably a 50 amp breaker. Everything's dependent on the distance that you're going with your wiring and how far you're taking that charge voltage. But these are just 50 amps. I'm using 2 of these, so I got a 50 amp going from the engine, that charge wire that's coming from the rectifier regulator, to this, and then to my DC to DC converter, and then once I go out of here, I go to another breaker and then straight to the battery. And then the battery goes from there to the battery switch and then back to the engine. So that way you can start the engine using the battery, but your charging system that's charging the battery is separate from that. You're going from the stator to the rectifier regulator to the breaker to the DC to DC converter or charger to the breaker to the battery. So it is a little bit more complex, but honestly it's not that complex. You're just taking the charge system and separating it from the start system, but it's all going to the same battery. Now, one thing to also consider, most engines, a lot of them, even, I mean, OX66s and a lot of Yamahas have a separate charge lead. So you can actually separate the charge system from the start system. Most outboards have that ability. There's going to be a wire coming from the alternator or from the rectifier regulator that goes to a post, and usually there is a secondary post right there close by where you can take that wire off of the charge coming from the alternator or the rectifier regulator, move it a post over so that way it's isolated. You've isolated your charging system from your main engine start system or the entire system where the engine is hooked up to the battery, and those two are now isolated and they run another separate wire. It's the same thing. Many boats have been doing this for many years, and that's how a lot of them are using ACRs and stuff like that. So they're charging, you know, 2, 3, 4 different batteries from single, twin, triple engine outboards, and that's going to isolate that charging system so they can charge all the batteries that are in the boat. And as boats continue to grow and as we continue to put more and more stuff on the boats, this is where the evolution has come in, because using lead acid is great. I mean, it's very stable, it's very simple, it's very safe, but when you continue to add stuff to the boat, it gets less and less usable and functional because of the weight, and because of the longevity, and because of the space that it takes. Because you can take lithium batteries and cut your weight in half, you can cut your space in half. Like, it's more efficient. The efficiency of a lithium battery compared to a lead acid batteries, there's no comparison on paper. Lithium will beat lead acid virtually on everything just because of the way the technology works. I mean, it has constant power, and it's just a more efficient way of using it. Granted, it took 15-20 years to get where it is today, and that's kind of what we're talking about. That's why Mercury now has a 48-volt alternator option on the V10s and the V12s. They have seen this where people on these larger boats, say you got a 39, you got a 42, you got this boat that people are staying on it. They don't want to run a generator. They don't want to carry diesel and gas on the boat. So if you just use an inverter and lithium batteries and eliminate that generator and all that stuff, you can use a 48-volt charger or alternator off the engine to charge a battery bank of lithium batteries and run inverters to run the air conditioner, the water heaters, and all the electronics on the boat. It is way more efficient, and that's what people really like. That if you don't have to listen to the generator and you don't have to worry about the CO2 issues and stuff like that, that is kind of where a lot, you know, the industry is kind of going that direction, but then there's some that are not going that direction. So it all depends, but the technology gives you that ability. And until we try stuff like this and actually learn stuff, I mean, obviously it takes research and development. You got to try something, see if it works. If it doesn't, great. If it does, even better. So that's kind of my opinion on it. I think it's great to try new things and to be able to use the technology that's available. And if it suits your needs, then by all means, I think it's a great thing. Also, when it comes to the starting of the lithium, most of your outboard starters, I think the big problem is going to be when you start talking about diesels and you start talking about inboards. An inboard big block V8 is going to consume a lot more amperage to turn that biscuit over with a starter than it is your 4-cylinder Yamaha or your 6-cylinder Yamaha or your Suzuki 2-cylinder. The amp draw on that starter is going to be so low compared to you know, that inboard, like your starter's probably going to have anywhere from 100 amps to say 200, maybe a little bit more amps, depending on how big the engine is. Obviously the V8 is going to take a lot more amps to turn over and get to start than the 3-cylinder is, but that's just something to think about. That instant amp draw on the battery, that has been a big problem for lithium, that for the most part, you know, companies like Epic have figured that stuff out. Like it's not that big of a deal. This thing can put out that amount of amperage to start that engine and then be boom, good to go. That's why it's a difference between a cranking battery and a deep cell battery. A deep cell battery is not going to be able to put out that amount of amperage in one shot instantly when you turn the key. A deep cell battery is more for longevity. It's more for a steady current draw of, you know, whatever you're consuming. If you're running one live well pump, that one live well pump on a battery is going to have a very minimal amp draw, and it's going to go for a long time. Whereas a starting battery or a cranking battery has an instant 160 amps drawing out of the battery at the moment you turn that starter on, which can be hard on the battery. So that is the difference in the deep cell and the cranking. But other than that, that's kind of what I've come up with and the way I understand it. I'm sure there's people out there that are electricians and that play around with batteries and they know 100 times more than I ever will about a lithium battery and all the other different complications and the chemical makeups and all that other stuff. But from my research and the people that I've talked to and from what I've seen with working on boats and working in the industry, that's pretty much the main thing, and those are the main concerns and complications of using a lithium battery with an older engine or a 2-stroke. It's about that stator and making sure that you stabilize the charge voltage that comes from the rectifier regulator or the stator on the engine before it gets to the battery, because as long as you stabilize that power or that voltage, then the BMS is not going to turn off, it's not going to disconnect from the engine, it's not going to overheat, it's not going to overdraw, it's not going to have any of those problems that it would if you were to go straight from your engine directly to the battery, which eventually it may work right out the gate. Again, as the industry changes, Yamaha with their new deal with Torqeedo and then buying that up, they're getting into the lithium space and having an actual company. Mercury and Relion, these companies are working with in-house lithium companies. So you're going to see this technology continue to advance where most of them are going to work out the box. You would think that as long as the rectifier regulator is doing basically the same thing that this thing is doing, I don't know about the heat, because obviously if you look at this thing, it's got a big massive heat sink on the back of it, so it's got to dissipate a lot of heat, which is probably a big problem of figuring out the rectifier regulator and the alternator for it to be able to stabilize that power right out the gate without needing something like this that's going to dissipate heat and, you know, you have other functions. That might be one of the complications, but obviously it looks like Mercury's figured out, because they pretty much all their engines now are all good to go straight out the box with lithium. The alternators, or they've figured out whatever. Again, I don't know, I'm not an electrician, but it seems like you would think that they can make the rectifier regulator do the same job that this thing is doing and have it be straight on the engine and have it good to go out the box. My guess is over the next couple years that will be more standard across all the brands. We'll see how Honda does with it. We'll see how Suzuki does with it. Yamaha and their deal with Torqeedo, obviously that's what they're trying to get to, so they're doing that much. But that's basically my understanding of it, and we'll see how it goes. You let me know what you think in the comments below.